Pero bueno, hoy estamos acá para hablar de CK-Sync y en específico acerca de la Elastic Chain o las Elastic Network. Yo soy Juan Fernández, estoy haciendo Developerability y estoy ayudando a los chicos de CK-Sync a través de la guild de CK Amigos en lo que vendría a ser su expansión dentro de Latinoamérica. Y vamos a tocar un poquito acerca de CK-Sync, por qué las Elastic Chains, account abstraction, ecosistema, pues los chicos van a dar un poquito de teoría in-depth más técnica acerca de todo este concepto. Antes de empezar y moverse en la Elastic Chain, quiero hablarles un poquito acerca del CK Credo, que básicamente son los conceptos en los que CK-Sync nos enfocamos, y creo yo que toda la industria blockchain en realidad, Trustless Security, todos estamos alineados en estos. Y si es verdad que Ethereum L1 posiblemente tenga un score mucho más grande que CK-Sync en la mayoría de estos conceptos, hay uno en los que CK-Sync se enfoca mucho, que es hiperescalabilidad, ¿no? Escalar todo lo que tendría que ser blockchain. ¿Y por qué? Hoy en día hay 5.3 billones de usuarios activos en Internet, son demasiados. Y en blockchain, ¿cuánto sería? En Argentina, 4% de la población, como muchísimo, debe estar utilizando blockchain. Somos 44 millones de habitantes en Argentina. No me quiero imaginar cómo llegamos a 5 billones de usuarios on-chain. Ojo, sería increíble, pero hay que trabajar duro para que la escalabilidad llegue a ese punto. Y es que, como al igual que el Internet no corre en un solamente servidor, el Internet de valor, que yo llamo las blockchains, tampoco corre en una sola blockchain. Mi visión de las blockchains es diferentes blockchains con casos de uso específicos, pero que al mismo tiempo sean interoperables entre todas. Y es justamente lo que estamos construyendo en CK-Sync con las Elastic Networks. Para los que no estuvieron siguiendo CK-Sync o lo hayan seguido, pero se hayan perdido un poco, básicamente en 2021 salió CK-Sync Lite, que estaba más enfocada a lo que son swaps, NFTs. Después de 2023 salió CK-Sync Era, que es la first CK EVM L2. Y después en 2024, no hace un poquito, se anunciaron las Elastic Network, que es todo lo que estamos trabajando ahora a través de CK-Sync. Pequeño recap visual, por si lo quieren notar o si le quieren sacar screenshot, pero básicamente CK-Sync Era hoy en día es la primer chain, en realidad, de lo que vendría a ser la CK Elastic Network. Pero entonces, ¿qué son las Elastic Chain? Básicamente son un conjunto de red blockchains verificables que están justamente protegidas por las matemáticas. Recordemos que CK-Sync utiliza CK Proof por todo el tema de seguridad y todas pruebas matemáticas. Y es que el concepto de elastic, que vendría a ser de elasticidad, viene justamente...
Perdón, hay que escuchar.
Metemos swap y hablamos en inglés. Ahora, let's talk in English. Presentation still on Spanish, but we can do it on English either way. Basically, where comes elastic from the concept of elasticity, and it's actually based on the more demand of users comes to CK network, the more the expansion that the chain will have. This makes us sure to still cover all the information that is coming to the chain. And you can think it with a little example that is, for example, a computer. You don't need to connect hardware, SSD. No, you can just use Google Drive, iCloud, Dropbox, and start putting content there. Elasticity, magic, right? About user experience, UX, CK-Sync focus on two principal concepts that I absolutely love, that are account abstraction and interoperability. My concept about blockchain in the future and CK-Sync concept is that we can only use one device, for example, my laptop, my phone. We can use Face ID, biometrics to sign in, create our own wallets, no need to download extensions, no need to sign transactions, no need to pay gas fees. We can use different CK chains, different applications in those chains without even know that we are actually using other chains, without bridging, interacting with other users, uploading documents. We can all do that thanks to interoperability. And that's actually about what CK-Sync Elastic Networks are doing. Imagine, I don't know, having $1,000 on CK-Sync Era, putting them on Aave, start making yield, and using that liquidity, I don't know, maybe on Lens Network, and start collecting posts from other creators on other chain. You can completely do that thanks to the Interop update that is coming to the Elastic Networks. About account abstraction, if you don't know, account abstraction is natively from CK-Sync, so hey, that's a blast for actually building on CK-Sync. And account abstraction is a general concept that has different things. The guys will probably go deeper on that later on their part. But basically, we have a smart wallet, so you don't need to download an extension. You just create a new wallet based on your email, based on your biometrics. And even for app developers, you can set spending rules. So, for example, a user can't spend more than $1,000 in 24 hours. That's a good security metric for onboarding new user, for sure. Easy login, again, biometrics, boom, you are inside the wallet. That's a seamless UX. And concept that I really love is account recovery, mostly for social apps. For example, Farcaster is one of the biggest protocols out there today on blockchain, and they are using a social recovery. So if you lost your keys, that's not a problem anymore. So Elastic Network, a little recap of what we just talked, but basically it's different chains, different CK chains, building on the Elastic chain. They are interoperable between all of them. Interoperability is natively, there's no friction, and most importantly, CK Sync uses CK Proof for security measures. Some examples about my favorite chains in the Elastic chains. Less Network, it's more focusedly on content creators. It's basically, they are building like a decentralized social graph, so you can post content there. And if we are thinking about social media, think about a Twitter. Like, you're posting tweets every minute. I'm not sure about the metrics, but probably millions of tweets every minute. So imagine that on blockchain. We need hyper-scalability. So second chain is for that. Also, about account abstraction. Imagine using a social media and needing to sign transactions using a wallet. That's a real problem. So again, account abstraction is super useful because the smart wallet, paymaster, etc. Another example that is super trending right now is Abstract Chain. Abstract Chain, again, is most focusly on consumer crypto. It's a hub for creators. You can tip other creators. They are using a global wallet, and that's amazing because you have account abstraction, you can create smart wallets, but it's only focused on one app. So one app, one smart wallet, another app, another smart wallet. A global wallet, what it does is that you always use the same smart wallet for every app, but in the same chain. And that's pretty innovative, actually. You can tip other creators, super useful. And the last example is Sophon, that they are actually doing CK TLS. For those that don't know, they are basically bringing creators online, on-chain. That's a great phrase, actually. But they are, for example, if you are a YouTuber or you have a channel on Spotify and you have like a lot of earnings, a lot of followers, you can easily put that information on-chain without needing to map your wallet with your social account. And that's pretty interesting and pretty useful to create different data endpoints for any other app building on CK chains. So yeah, that's all for my part. I hope you enjoy it. And guys, I will give you the role.
Te robo. Te saco todo. Ahí está. Almost there.
Almost there.
No, don't change origin. No. Almost there. This one. Oh.
Right. Well, thank you everyone for being here. Thank you for having us. We work at Motion Labs. We work in particular in the field of developing technological solutions for CK Sync. My name is Miguel Huerta.
And I'm Juan Riada, and the talk we are going to do today is every chain, every user, all at once. I know it sounds familiar from a famous movie. It's not. It's just coincidence. And I'm sorry in advance that I'm extra not funny on English, and I will try to do my best.
So let's start. The first thing I want to talk is about, well, Juanpi has been talking just a moment ago about like these different chains, these different chains built on the Elastic ecosystem, that they all have different properties. And well, basically this morning I just woke up and I said, hey, I want to have my own chain. But then I started to feel frustration because that is so hard, right? And you need to do a lot of things. You need like your own validators, you need your own economics, you need to develop wallets. And that frustrated me.
Miguel, you don't have to know anything about that. You just have to have a minute to discuss CK-Stack with us. CK-Stack is this new framework developed by CK Sync, and what it allows you is to create your own CK chain, fully customizable, and with every parameter you want, every configuration you want. If you go for gaming, if you go for DeFi, Juanpi talked a little bit about soft phone. There are other use cases, and you can customize your own, and it's as simple as just using CK-Stack.
Yeah, and what you can do to achieve this, I don't know, NFT-focused app or social-focused chain is to change parameters on the deep level of how the chain works. So,
for instance, here is us creating a CK chain, I think yesterday. This is a little bit with the magic of the cinema because it's going to be a little bit faster than normal, but here you are just installing CK-Stack, and also a requirement for CK-Stack is to install Foundry. Not normal Foundry, but Foundry CK Sync, because we are going to be deploying a lot of contracts. So here we are doing CK-Stack ecosystem create. We have to keep in mind that CK-Stack differentiates ecosystem from chains. In an ecosystem, you can have multiple chains. So it's like a way to group different chains. For instance, here we are creating an ecosystem called Lumon. I don't know if you watch Severance. Severance fans here, anyone? Really good TV show. We are cloning CK Sync Era. We are creating a chain called Cold Harbor and the chain ID 271. And Miguel, if you want to elaborate a little bit on the...
Yeah. Totally. So here is asking us to provide no proofs or CPU. Basically, our chain is going to live as a second layer of some other chain.
Yeah.
So this option is to calculate zero-knowledge proofs for the execution in our chain and send it to the base chain. And this is, to me, is one of those crazy things because as soon as you choose GPU, we are not going to use GPU right now, but if you choose GPU, basically this is going to spawn a prover for you. A prover using Boson. Boson is a technology created by MetaMask, by CK Sync, that is basically all the buzzwords about CK that you can choose all together. Like it uses stars, it uses snacks, it like super optimized to run in like normal grade GPUs. Basically, if your computer can run Call of Duty, it can run Boson, and it's there. So you just need to click that thing and then you need to select GPU, and you have like a AAA zero-knowledge technology running in your computer for you.
Yeah.
Which, by the way, is open source. It's totally well documented. So I totally recommend you to try it, just even to learn how it works. And the next thing that I want to ask us is about like it's about if we want here. If we want to, our chain is going to have its own state, and we might want to send the how we build a state to the base layer. That is usually called a rollup. Or we can decide not to send the state differences, and that is usually called validium. If you choose one or you choose the other one, you have different properties on your chain. Both are valid options, but here selecting that is, again, a lot of infrastructure is just an option in this wizard.
Yeah. And also here you can choose even the base token. Like, of course, in the chains there are going to be fees, and users are going to pay fees. But you can change in what like token you pay the fees. For instance, I think in Softphone they use SOF as the base token. Here we are just going to use ETH, but if not, you can pass any ERC20, and the user will pay the fees in that ERC20. After that, of course, we are going to select ETH, some more configuration, and finally, it asks us, hey, do you want to start a containers? Because under the hood, these are just modular components in Docker containers. So there's not like black magic here happening.
Yeah, and it is like the same, like under the hood, it's the same infrastructure that is securing basically everything that is like the internet and everything that requires security, right? And also the same technologies that we use to deploy other apps. So if you're familiar with web development or with any kind of development, you can go in here and understand what is going on because this is just Docker at this point.
Yeah. Now it's initializing the chain, it's deploying the system contracts, so we are going to see a lot of broadcasting happening now, and also compilation with CK-SOL-C and SOL-C. We are just initializing the chain. As Miguel said, this is like the same thing as CK Sync Era you have here in your CK chain. It's not like you are not missing out on anything. CK Sync Era has the same properties as your CK chain. Here we are broadcasting a lot of things because, for instance, we are deploying the system contract, we take care of the balances, the nonces. If you want to deploy something, you go through a system contract also.
This is another, like the system contracts are another cool part of this. Like part of the design of the elastic chains is that a lot of the important parts that happen inside the consensus of the protocol happen in these system contracts that, as you can see, we are deploying them here, which means that you can even go and change stuff on there. And since as core as, for example, the balances of the accounts or how you handle the nonces, or basically a lot of the core parts of the chain are in those contracts, and you can go and personalize and put whatever behavior you consider is right for your specific use case.
Here we already have the chain going, like we started the server. Here you can see we are sending things even to L1, but this is pretty boring just looking at this. So the next thing we're going to do, and the next thing that CK Stack allows you to do, is to create an explorer for you to be able to see what is happening. The explorer consists on two things, like a pretty web normal app. It's the front end and the back end. So we're going to start by initializing the explorer. Here we are going to do CK Stack explorer init, just this basic configuration so you can point the explorer to your chain because you can have multiple chains, so with multiple explorers. Next, we're going to start the backend of the explorer, which is pretty boring itself. And then we're going to start the front end of the explorer, Docker doing Docker things. And finally, we are going to start the front end and go to the front end like this. And you get the same exact explorer you get for CK Sync Era or for mainnet, for Sepolia. You get the exact same thing with the exact same features. You wanted to add something?
No, well, the same thing. Because this is open source, even again, if you want to change it, you want to customize it, you are invited to because it's open there for anyone to do whatever customization they want.
We see that the chain is already started, we have some blocks, we have some transactions, and we have our network as the main network in the Explorer. Next thing we want, we have the Explorer, we have the chain. We want to interact with the chain, we need balance, we need funds. So we are going to start something CK Stack calls the portal, which is just a tab that allows users to bridge funds and to also see the transaction history and send funds to another person. This is the portal, you don't have to do pretty much anything, just start the portal and just touch whatever and miss the whole presentation here. Okay, so we're going to start the portal. This is the portal, and we're going to bridge some funds from our base layer, which is red in this case because we choose localhost. So after doing this, we're going to send us some balance, and yeah, you can.
No, same thing as before. This is the portal used in production right in Era. And it's a familiar experience to what people are used to seeing bridges in the chain, right? Like in production environments. And again, it's all one command and you have it all together working at one time.
We're reaching, and that's it. And if we go to our account, we are now rich, luckily. And also, if you go to Explorer, we can see our transaction. This is my account with only one transaction, that is this funding we did with this obscene amount of ETH.
Well, okay, so what we did with this command for creating our own ecosystem, our own chain, is deploy our elastic chain. That is not a monolithic system. Instead, it's a series of services working together. You have, for example, the prover that is in charge of this portion that I mentioned before, this algorithm to the CK proof of every transaction execution. We have our CK VM, we have our portal, and an explorer, the two front ends that Juan just showed. The server, this is basically what is in charge of taking all the transactions and put them in the right order, and it's like the core of the situation. The smart contract that we use, and well, you can go there, and if you do, when you run this, you can do like docker ps, and you're going to see the list of processes, and it's the same, like, it's totally familiar for whoever has some experience working with any kind of application. And also, the other amazing thing is that, okay, we developed our chain, we created our chain, but the chain is not isolated. The chain is part of the Elastic network ecosystem. So now, just by being there, we are compatible with a lot of stuff. We are compatible with sharing bridges, we are compatible with every technology that points to the Elastic network, and that I make us start from a lot upper point, right?
Yeah, and also the system is not alone, and you as a developer are not alone also, because, well, batteries are included. That means like there are a lot of tools that you can use that are already working. There's a lot of contracts that are plug and play. You can use like deploy Uniswap, you can use deploy Aave, and you have tools you already know, like Hardhat, for instance, or, sorry for the self-reference, but you can use Foundry CK Sync also, which we are the team behind Foundry CK Sync. If you have issues, you can raise them to Miguel. But
well, so just to do a small recap. At this moment, we have our own chain, which all the components and all the basic things are needed, like an explorer or a portal. We have apps. We have like a script that deploys Uniswap in our chain, and that is like open source. We can use it. We have tooling for our developers to work in our chain. The only thing that would be awesome now is also make the interactions of the users with our chain as smooth and as easy as possible. So here we go to this second chapter, every user. So, Juani, you told me that these things were users.
No. I never told you that. These are public keys for me. They are not users. Users don't exist.
That is the classical discussion between like UX and blockchain, right? Like, for that reason, we keep thinking that a user is an address. And a user is not an address. An address is a hash of a public key, and that's not enough to represent the complexity of a user interaction. So if we start thinking a little bit deeper, maybe what we can start like finding the difference between signing, which is what we always say, like we sign a transaction, that's the word that we use. But maybe what we want to start thinking is in authorized. What we want is authorized interactions.
Yeah. Even if you go to a shop and you pay for something, like behind the scenes you are authorizing that amount of money to go from your pocket to the shop, for instance. So we want to abstract a little bit from the implementation term of signing to a more authorization, because you can authorize using your credit card, your cash, you have a lot of methods to do it. So we want to abstract a little bit from signing to authorization.
And then we want to think on this case study.
Yeah.
Imagine that we have a wallet, and that wallet is shared between two people. So what we want is to ensure that those two people have to both provide authorization in order for the transaction to go through. So the way that we're going to implement this is like the client or the JavaScript code. We are going to show code in this talk. I hope that everyone is comfortable. But the idea here is pretty straightforward. When we create our wallet, we are using two private keys. These are going to be the two users that are going to be part of this interaction. And then, when we want to authorize the transaction, we want to just get the two signatures and send them together and use that to authorize the transaction. So, how do we make this work on the other side, right? Like that was the client, we want this to work on our chain. So for that, we're going to use this concept of account abstraction, and we're going to try to explain how this is implemented by Seek and Sync in the Elastic ecosystem. Basically, there is like these three main methods: validate transaction, execute transaction, and pay for transaction. And there is like a little plus that is check if a signature is valid. That is also another thing that a user might want to do, right? Maybe you are not exactly doing a transaction, but you have something off chain that you want to check that you were the author. So, Juani, can we
of course.
So this is kind of how it works. What our chain is going to do for each transaction is first take the account and ask it, hey, this transaction is valid for you? Like, are you agreeing with me executing this transaction? And if the account returns no, well, there is an error, the transaction is not executed, and that's it. But if this returns true, then it's going to ask for the account to execute the transaction. And lastly, of course, pay the fees, right? So that is basically what the system is going to do with the transaction.
But what we have to do from the Solidity side? Well, it's pretty similar to what we showed in JavaScript, but for instance, this is a two-user multi-sig contract that implements this trait, as Miguel mentioned, with the functions we need. Validate transaction, execute transaction, and pay for transaction. And it's implementing iAccount, which includes these three methods. So the same applies here. We have two addresses, like let's say it's a wallet between me and Miguel. So Miguel's account is the owner one, and I am the owner two. For instance, the constructor, pretty self-explanatory, is mainly the same. But we see here in the real implementation that we are calling this validate transaction, which is the same function Miguel explained in the pseudocode we saw earlier. That here it's interesting because we can see a little bit into the implementation or the inside of CK-Sync. Because for instance here we increase the nonce. We always hear this hey, when you start the transaction you increase the nonce. Okay, here we see how the nonce is incremented. It's not like magic. We are calling a system contract which knows the nonces of the accounts, and we say, hey, please increase these nonce. And also we are checking something obvious, that we have balance to do the transaction. And after that, we are checking also the signature. Miguel, if you want to...
Yeah. So, well, eventually, we verify the signature. It's another method of the same contract. And again, this is just validations on the structure of the signature. And eventually, through ECDSA, verify a signature using elliptic curve. And well, what you can expect, right? That we just verify the two signatures and check that both of them are true. And what I love about this is that eventually the implementation matched pretty well with what we expected it to be, right?
Yeah. So we validate. Now, if everything is fine, we need to execute the transaction. This also gives us a clue about what's happening behind the scenes. We have a special case there, which is the first if, that if the two you are sending to is the deployer system contract. This is the difference between, for instance, an EVM. To deploy contract here, you need to call a system contract, which is the contract deployer, and you need to pass in the factory dependency, the bytecode. We don't have to go into that, but this is a special case of a transaction, and so if it's a deployment, you call the system contract deployer. But if not, you do a normal call. That's it. There's no any other magic here. And lastly, you pay for the transaction, which is the last method.
Yeah, just a comment. All of these snippets were taken from the, if you go to the account abstraction page on the CK-Sync docs, were taken from there, and there is even deeper explanation there regarding more comments in the code and stuff. And it's super interesting. Every example on that repo is something very nice to understand how everything works under the hood.
Yeah.
So this is the idea of account abstraction, and to me, it's a little bit like the sky is the limit, right? And you can implement whatever kind of interaction from the user that you want to validate their identity. As soon as you can code it, you can implement it. And not only that, if you just start thinking that you can just code whatever you want, you can start doing things okay, in this situation, validate this transaction in this way, in this other situation, use this other way. You can think in a web tool, this could be something like, normally you validate your identity with your password, but if you forget your password, you validate by proving that you have certain email addresses, right? And not only that, you could start thinking, okay, if these are modules that I can take in and out, right? And I have an account that I can build with different parts. And this is the idea of the modular accounts. And the amazing things of the modular accounts is that they are ready built for us, ready for our new CK chain. So the last chapter, right? Now what we want to do is take what we have in our new chain, take this idea of account abstraction and mesh it all together. And if you have another second, I would like to talk about passkeys. Because if we are going to integrate with a Web2 experience in our chain, we should not take the Web2 experience of the past. That would be passwords, right? Passwords have all sorts of problems. People lose them again. And then after that, hackers take like control over those passwords and hack people's accounts. So the solution that the industry got to this are passkeys. Passkeys are a W3C standard that basically allows devices and browsers and OSs to generate keys for the users, and those keys are scoped per domain. So there is no possibility of phishing in that case.
So Miguel, you're saying to me that we can have security, transparency, decentralization, and also Web2 UX? Like my mom can use this?
I'm not only telling you that, I'm telling you that it's already there and it exists and it's ready for us to use. And it's called SSO, Smart Sign-On. And we are going to show you in a second. This is already working on Sepolia. We're going to show the CKC Sepolia version. This is again public. Anyone can try it. And we're going to see that what is happening right now is that Spanish browser is requesting for authentication using his fingerprint, and that just created an account on CKC Sepolia using this contract, the SSO. And this is Spanish address, and if you search for the address is a contract. And we can even, like if you go to a contract, we can even, I mean, it's not verified, so we are not going to see a source code, but this is the bytecode of the contract. And well, this is already using this idea of the account abstraction, and it allows you, like it's a modular account, anyone can develop more modules and add them. So this is there, and it's ready, and it's open source. And actually, if we go, is the camera go with us, and we go back to the... Awesome. This is open source, so you can go to the repo and check by yourself how it's implemented. There is a few parts that we want to highlight. This is a function that puts the passkey signature into a transaction. This is VM. Before, in the previous example, we used ethers. Those are the most common, I believe, tools on JavaScript to work with Ethereum or with EVM. Both are available for the Elastic Chain. One also mentioned Foundry, so the most powerful tooling is there. And if you see this function, this is like first, this is requesting the browser, hey, please sign using the user passkey and use the hash of the transaction as a challenge to sign, as the thing to sign. And lastly, this function just formats everything in the way that smart contracts expect. This is the contract side. As you can see, this is basically validate transaction, and it calls Web25, sending the signature. And the Web verified to me is another super interesting story because it does Web2 validations. Like it checks that the cross origin is right. We summarize a little bit this method, but there is more Web2 authentication at this part. And lastly, it finishes doing P256 verifier. This is Elite curve. It's a different Elite curve that the one using Ethereum, but it's still Elite curve. It's the same kind of cryptography. And I mean, it ends up in a terrain that is well known. You just need to implement that cryptography, and you can use passkeys inside your contracts.
So yes, we can have both.
We can
basically
have both.
So yeah, just to end up, we wanted to make a quick recap of 3 points. Like you saw, creating a CK chain is easy. You can do it yourself. You can do it now. You can fully customizable. It's super easy.
And not only that, also all these components that the CK stack is using are open source and are ready there for you to go and go as deep as you want and learn how they work and how they interact together. Then, well, account abstraction is native in the protocol. It's just an extremely powerful tool that brings a lot of possibilities in the table for everyone to try it.
Yeah. Not only for everyone to try and to tinker with, but also to try to think a little bit different about how we think about users. Like they are not just addresses, they are users, they are people that want to use our chain or want to use the protocol, etc. So this account abstraction enables us to start thinking that way.
And well, SSO is kind of one example of the powerful and the versatility that you get when you use these kind of technologies. So I believe that in certain ways SSO is for sure. Let's use it, but also it's an invitation to explore what other things can be done with these technologies.
Yeah. So this was every chain, every user all at once. Thank you.